Alright, this little mini lesson has to deal with composite functions, and I'm going to start by trying to explain what a composite function does. It is a function of a function. Basically, it's when you stick two functions together. But let's look at what happens when we do a particular thing. Let's say I've got function f is up here. Let's say I want to find the f of 2. Okay, remember what we do. We take 2 and we plug it in for x in the function. So it's 3 times 2 plus 2. And I get 6 plus 2, I get 8. So the f of 2 is 8. Now let's say I take this answer and I plug it into function g, and let's say I want to find now the g of 8. Okay, so I took the answer from f, plugged it into g, and that is 4, and it says plug in 8 for x, and so I get 8 squared, which is 4 times 32 in some worlds. How about 4 times 64? And that is 16 carry 1, 256. Okay, so I took a number 2, plugged it into f, took that answer, plugged it into g. So what we'd say is this. We would just say the f, how about the g of f of 2 is equal to 256. Essentially, that's a composite function. So what I did is I ran 2 through function f, let's use red here, ran 2 through function f, took the answer to that, which was 8, and ran 8 through function g. So let's keep a little note of that up here. The g of f of 2 is equal to 256. So now I'm going to show you the power of a composite function. In this problem, I had to run it to two functions at once, or one after the other in succession. And so it would be nice if I had one single function that did both of these things at one time, and that's exactly what a composite function does. So I'm going to build a composite function by going g of f of x. And what this says is take f of x and just plug it into function g. So it looks like this. I'm going to start on the inside, and I still rewrite my g. I replace f of x with what it's equal to, 3x plus 2. I just pulled it down from up here. And then I find the g of 3x plus 2. Again, I plug this into function g. And it looks like that. So function g says take 4 times x squared. My x squared got replaced with 3x plus 2. I'm going to clean this up a little bit. That's 4. I've got to square that binomial. It's 9x squared plus 8 plus 12x plus 4. And I'll distribute that 4. 36x squared plus 48x plus 16. So that is now the composition of function f into g. And what's neat about this is I can actually then use this function to do things like find the g of f of 2. Instead of using function f first, then plugging that answer into g, I can use this newly developed function down here. I'm going to erase a little bit. Hopefully we can leave that brand new function down there. We'll cut that out. Okay, and I'm going to let me erase a little bit of that stuff. Let's see if we can move him up a little bit higher. There we go, that's not too bad. So this is function g of f of x. Notice the x is in there and it's inside of this new function. Now let's find the g of f of 2. Work would look like this: 36 times 2 squared plus 48 times 2 plus 16. this is 36 times 4 plus 96 plus 16. That is 144 plus 96 plus 16. That equals 240 plus 16, which is, I'm running out of room, 256. Okay, so I get exactly the same answer. You're like, well, that was a lot of work. Well, picture the fact that you'd have to, if you're a computer programmer or just a person doing this many, many times, if you wanted to evaluate a bunch of g of f's of 2, then 3, then 4, then 5, rather than run it through f, then through g, you have one function, you run it through one time. So you can plug 1 into this, 2 into this, 3 into this. So you only have to hold one equation in that case.